Hello friends, welcome to our channel Engineering and Technology for You. The topic for today is data transfer operations in simulator. Here we are going to understand the 8085 data transfer instructions with the help of simulator. Now data transfer operations simply copy the data from the source to the destination, and the source may be register, memory, or even the immediate data. So let us begin with the first instruction, that is MVI data, and then we'll go for the MOV R1 R2. Now MVI data, this is the instruction which will move immediate 8-bit data into the register R. Now this is simulator software kit 1.0, which is available on the internet, and I have also given the link for this in my description. So you can click on the link and download this simulator. It's a very simple to use simulator. Here with the help of this icon we can put the new code, and here whatever code you have stored you can open with the help of this icon. And then we have the blue icon for running the program, and this another icon for stopping the program. Then the simulator displays all the registers A, B, C, D, E, HL, then even the memory, stack pointer, and program count. And this side it gives you the address and data. This is the X code grid which gives the program after when you run the program, and this is the user data grid where you can give the data in the form of address and data. Now on this side we have push button switches for the instructions. Now first group is the data transfer group. So simply clicking the instruction you will be able to take the instruction to the editor. So let us begin with the MVI data. Now the example for this is MVI I will take. So first I will click this MVI and then simply A, and then you have to give the number. So I will take 11. So MVI A 11H. So the first instruction is here. So if I run the instruction, so here the opcode for this is 3E and 11 is the data. So it's a 2-byte instruction. So it will load A register with 11. You can see here it is loaded. Similarly, you can make use of the instruction for loading other registers. So for example, MVI B will take 22, then MVI C I will take 33, then MVI D I will take 44, MVI E I will take 50. So in this way I have given these instructions here. So when I run the program, the opcodes for these instructions will be coming on, and the data will be loaded the particular register. You can see here A is already loaded with 11, then B 22, C 33, D 44, and E 55. And these are the opcodes for this. These are all single byte instructions. So 0E, then 161E. These are the opcodes for the MVI E, MVI D, and C. Then let us go to the next instruction. There is MOV R1 R2. So this instruction MOV, it is copy from source to destination. So the source is R2 and destination is R1. So here R1 and R2, again we can make use of the different registers of 8085. We'll try to execute this move. Now here whatever data is available in A, we'll put it in H. So I'll put H A, and similarly move L B. So A to H and B to L. So whatever data is available here, A is 11 and B is 22. So that is go to H and L. Let us run this. Now you can see H is 11 and L is 20. And this is the opcode for it. So in this way, you can use the move R1, R2 for moving the data between the registers. Now let us go to the next instruction, that is LXI RP data 16. So this is load 16-bit data into the register pair. So if you are going to make use of this, then the 16-bit data which we are giving here will be loaded into the register pair, for example HL, DE or BC. So let us take LXI, then H2250. So that is the instruction we are taking. So this address 2250, let us try to put it here. So let this become blue, so it will be easy for you to put the address 2250. Similarly here you can put the data by double clicking it, and here I will try to put the data 99. Now when we execute the instruction LXI H2250, the address or this 2250 will be loaded into the HL pair. So here it is 00 now. When I run it, it becomes 22 and this becomes 50. And the opcode for this is here, it is 21. This is the lower order byte and this is the higher order byte. So this will be loaded into L and this will be loaded into H register. Then let us take the next instruction, move R, M. So whatever is, we'll put it here, move, then here register, M. So for that we'll put it in the A register A. So when we execute this, whatever is the data in this location 2250 will be loaded into the accumulator. So here you can see M is 99. So this data will be going into accumulator, which is 0. Now it has become 99. Then the next instruction is move M, R. Now in this case, you have to load the data from register to memory. Now here already we have loaded the data into memory. So let us load some data in B register. So MVI, suppose I take B, and here I can load any data. Suppose I take it as say 22, and now I will try to put the data. So B is 22, and now I will try to put it in the memory, is 2250. So we'll again make use of the move instruction, and this time M, R. So M, R. So move M, B. So from B the data will go into the M or memory pointed by HL. So here presently it is 99. So when we execute this, you can see So whatever is in B22 is loaded here. Here you can see the date. In this way, we can make use of the instruction move m comma. Then let us go to the next instruction. Again, here we can clear it by saying no. We'll go to the next instruction. Then let us go to the next instruction, LDA address. So this is immediate addressing. Here we are loading the accumulator with the data from this memory location whose address is given in the instruction. Say for example, we take LDA and 2450. So this will load the data from 2450 into accumulator. Let's execute. So this is the opcode, 3A is the opcode, 50 and 24. This is the address of the data. So this address we are having 25. So that is loaded into accumulator. You can see A is 25. So similarly, now we have another instruction, that is store accumulator direct. So here we are giving the address for storing the accumulator. So now this 25, we want to move to this 2450, then we'll have to give the instruction STA, then the address is 6450, 645, so STA 6450. So when we execute, now presently it is having 00. So when we execute this, we are getting 20. And this is the opcode, 32 is the opcode, 50, 64, that is the address. So in this way, the STA instruction will work. Now let us go to the next instruction, LHLD address. It is load HL direct. So here the address is given. You have to load the HL pair from the memory location given by the address. So let us take the example. Here LHLD will take 2780. That is the address. So it will take the data from 2780 45 and that will be loaded into the L register, and then next address 2781, the data is 72, so this will be loaded into the H register. Let us see. And here you can see this is the opcode 2A, then here we are giving the address. So you can see this 45 is loaded into L register and 72 is loaded into H register. So that's why we are able to load 16-bit data from memory to HL pair directly. So in case of 16-bit addition, we can make use of this instruction. Then if you want to store the HL directly to the memory location, then we can make use of the next instruction, that is SHLD. So let us take SHLD. Now this time we will take the address 3460. 3460. So whatever is the contents of the memory location, say whatever is there in HL, that will be loaded into this memory location. Let's run it. You can see so 45 and 72. So this was there in H and L. 45 is in L register, so that is coming into the first address, and H register it will go into the next address. So in this way we can directly store the HL pair to the memory with the help of SHLD address. Now let us go to the next instruction, LDAX RP. Now this instruction is for loading accumulator indirectly from the register pair. So we have for register pair BC or DE register. Here HL register is not possible because already we have separate instruction for that. So let us take example here. LDAX, I will take B. So before that we'll have to load B. So first we'll cancel this. We'll take LXI B 2150, and then now I will make use of the instruction LDAX B. So when you execute, now here first 2150 is loaded into the BC register, you can see, and when we execute the LDAX B instruction, whatever is there at this memory location 2150, so 2150 it is 77, so this will go into the accumulator or A register. So that is how will be executed. Then we have the next instruction STX RP, that is just opposite to this. So this will store accumulator with the register pair. Again B and C register pairs are only allowed. So again what we'll clear this program and now try to load some data in register so that it can be loaded into the memory. So I will take here MVI, first MVI A. I will just take 22, and then I will take LXID, and here I can take 2560. And then I will give the instruction STAX. Now here we'll have to specify the address 2560 with some data. I will take data, let the data be 00. So now when we execute this program, so MVI A22, so 22 will be loaded into the accumulator, and then we'll load DE with 2560, and when we execute this STXD, whatever is the content of 2560, so here we are storing the accumulator to this 2560, so here 22 will come. So you can see first the accumulator is loaded with 22, and then DE is loaded with 2560, and then STXD, that is store accumulator indirectly with the memory location addressed by DE pair. So the memory location addressed by DE pair is 2560. So the contents of accumulator 22, they are loaded in this memory. In this way the STAXD will work. Then the next instruction is XCHG. Now this is for exchanging the contents of HL pair with DE pair. So in order to understand this instruction, let us first load the HL pair and DE pair. So we'll take LXI H 2550 and LXI T 3549, and take any data here, no restriction. So when we execute this instruction, we are getting DE 3549 and HL 2550. Now when we execute the exchange instruction, just take the XCHG instruction. So when we execute this, so this data will be exchanged. DE will be exchanged with HL. You can see here. Now you see DA has become 25 and E has become 50, HL 35. So in this way, we can exchange the contents of HL and D with the help of XCHG. So with this, we come to the end of this first video with the simulator. I hope it is easy to understand the instructions with the help of simulator. We will be coming with future videos will be on the logical, then arithmetic and other instruction set of 808. So thanks for watching. Have a nice day.